computer. That way I have control over what goes on in this recording, because I've got a massive monitor that actually needs to be replaced because it is not that great. It's been having issues going on. So okay. So 1 second. Yeah. Yeah, I mean, well, it's part of the costume. This is the dating outfit for a Papyrus from Undertale. So he's normally in armor, but he wears a backwards hat in this outfit. So my kid is going as Sans from the same game, and yeah, they do. I think that's the point. And my wife is going as Toriel. So we generally try to go theme together. So let's see. So part of this today was checking out what we're going to be doing for the remainder of the semester. Let's see. So next week is already, so yeah. So based on so let me go ahead and share my screen, because we need to go and figure out stuff. I don't like the way that where this is gonna put the exam, which is right before the break. But hey, it's gotta be what's gotta be, I think. So because I need to get you all started on your project. So let me go ahead and let's not do the 4th. That final project is, so the last day of classes, double check this for me, right? Last day of classes for Temple is just registrar, right? So if we check fall 2023, the last day of classes is Monday, December 11th, which means that our final project will be due Monday, December 11th. Okay, so I make it due then, because that is literally the last minute I can take it in. This is one of the few things where I have the deadline. So the final project is one of the few things. It's actually the only thing besides an exam that I consider to be just a hard deadline, no flexibility on it. And I say that, but of course the caveat of, okay, you just got had a medical emergency, not got sick, but like ambulance stuff. If you get sick, turn in what you have, because I'm trying to see what you did over the course of a month, not what you scrambled to do at the last minute. Excellent question. We're going to discuss when exam 2 is in just a second. Okay. So because that's the 11th, because this is the 11th, is due December 11th. That means the latest that I want proposal day to be is the 11th, which is a Saturday, and I can't do that on a Saturday, which means that proposal day needs to be November 9th. So, as a result, intro. So proposal is due the 9th. We have it that day. And because it's due the 9th, and so since the proposal day is due the 9th, that would mean the exam would need to be on the 7th be on the 7th or the 14th or 16th. I wouldn't want to do it on the 7th because I want that day to review, which would make Thursday the review day, but then I'd have no time to go over the GitHub lab. So that just doesn't work. So it's not going to be the 7th. So given that I want a review day for the exam will be on the 16th with a review day on the 14th. Make sense? Okay. So I've kind of convinced myself with this that the exam most likely will be on the 16th. So basically 2 weeks from now. 16 days from now, in fact. So quite a far distance, but it will definitely then cover a lot of things. You'll have a few practice exams as a result, or more practice problems than you normally would for that. But it will go over. Well, let's go ahead and take a look at what exam 2 looked like last semester, shall we? Or practice exam for last semester. Okay, let's see, practice. Do I not have it uploaded here? Uploaded. Practice. Yeah, exam 2 practice. All right, so a few things here. Main difference between, so there's some theory questions here. Those probably won't appear. This one is an actual question I asked once on an exam and it's now become it's now become a practice problem for all my exams. Suppose we have a file called temperature.csv, which contains the daily high and low temperatures recorded in Philadelphia. The file's composed of 3 fields per line, containing the date, the high temperature, and the low temperature. So, and each field is separated by commas. For example, the contents of the field might look like this. And then I have this table here, 11, 11, 19, 64, 40. They're just separated by commas. There's not actually spaces there, but the spaces wouldn't matter for how to handle this anyway. Write a program that calculates the following: the day with the hottest high temperature, the day with the coldest low temperature, and the average high temperature of the entire file. Make sense so far? So that's a very kind of archetypical program that you would expect to see for a file reading question. And another example question. We have a file called numbers.csv that has 5 numbers per line separated by commas. Give me the sum of all the even numbers in the file. And then I have a few of these very good practice methods that I'll go over in class, but here's one like, if the word begins with un, remove the un. If it doesn't have an un, add un in front of it. Give me the difference between the biggest and smallest items in the list. Given a list of numbers, change it so that 2 items have been swapped. Given a input string word, return true if word has the string cat, but the middle A could be any character. So tomcat and catnip with the spelled in leet speak over here would both register as true. And then some other ones I grabbed from Coding Bat, which are some good questions there. But these are a lot of, hey, given a method, fill this out kind of questions. This one, does it have? Yes, it does. Okay. Then this will now be part of exam 2 because we don't have an exam 3. But then we have a few Monte Carlo practice questions. You will definitely get a practice question. So this one's called Penny's Game, and I plan on going over it today. So we'll go over this later. We do have a final exam. In the previous semesters, I had been doing exam 1, 2, 3, and final exam, and I found that doesn't really work for this class. So I've been doing 1, then a late exam 2, and then a final exam. I think so. I'm not really gonna double check it. Oh, and yeah, both the Monte Carlo questions are here. This one was also a Monte Carlo question from one of my exams. And this one I think is really good example. I've refined it a bit more, but the notice that I have for this question, a grading marker. You can expect to see the rubric for every question, for all these coding questions on the question itself. That will tell you what I care about, as well as kind of give you a hint as how to program it. Make sense? So here, so I plan on going over this stuff in a bit, but I just wanted to say, this is the kind of stuff you'll be dealing with. A lot of list kind of manipulation, or string manipulation or parsing questions. They are open note. The restrictions are very straight, are very, basically, I'll go over the more formal rules later, but essentially, so long as you don't use the internet to Google the answers or to communicate with other people, it's free game. It's fair game. So long as, no, that'd be technically communicating, but no, not ChatGPT. That's I have it specifically. No, you can't so no, what I have is that basically you can use any note that is, and yes, these will be the same for the final exam. You can use anything that is on your computer. Here, give me 1 second. I'll pull it up. Here, I'll pull it up. I've got let me pull up the exam and I can share my screen with the rules so that we can all see it. So we can all see the rules for exam, for the upcoming exam. And again, that exam will be on the 16th. We determined it. That is not that. We want, okay, exam. So preview. Okay. Actually, yeah, there we go. That is actually everything I need. Okay, share screen. So this is from the exam 3 write-up, but the rules are the same. It's exam 3 from a few semesters ago. Again, there is no exam 3, but here. So students can complete the exam on their own devices or on a lab computer. You have to be physically there to actually take the exam. Students can use any coding environment of their choosing, IDLE, IntelliJ, Eclipse, NetBeans. So you get to actually type your code out this time around. The exam is open note. The notes can be on paper, any amount of paper in any form, including the textbook. The notes can also be notes or code stored on the student's computer or personal cloud. So anything you decide to download in advance. Students may use any resource on the internet that is linked to from Canvas, such as my YouTube lecture videos or the lecture recordings or my GitHub repository. That also does refer to the textbook in this case. So, the textbook, you can use that. Okay. Students may not use the resources on the internet that are not on their personal cloud, nor those linked to on Canvas. Yes, one note would count. Basically, anything that is, the point of the rules is there's no exam 3. There's only exam 2 and the final exam. Exam 3 was last semester, but this was the easiest to pull up. Okay. No, there's going to be a lot less questions. Let me go ahead and check. Yeah, no, the exam hasn't been shared yet for practice. I will share it once I do it. Yes, that's your cloud. Your Google Docs are allowed. Basically, the entire spirit of the questions is that I don't want you to be able to go and look up the answers, on Google, or to go to Quora or to Stack Overflow, or be able to chat with other people. That's kind of the spirit of the whole thing. Yeah, you could totally download anything you want. If it's been downloaded and it's on your computer or on your personal cloud storage, yeah. If you want it, I recommend downloading maybe the Python docs, although the Python docs are found on the syllabus, which therefore are linked to from Canvas. No, I have not. Oh, geez, I've completely forgot about the exam 1 point requests. Okay, so I will have to get to that. Let me go ahead and actually put that in so I look at that. Will there be a curve? Only at the end. I don't curve individual scores for things. The curve generally changes the range of what an A and a B is. Last semester, 90 and above is A. It's always 90 and above for an A. What it changes is what an A minus is. An A minus was last semester an 88 or above. And a B minus was like an 80, it was like a 79 and above. B minus was like a 79. Okay. Okay, putting that in. There we go. 16th. So, all right. So now we understand the rules there. Let's talk about, so now that we've got our, now that I've talked about that, let's talk about what we're doing. Okay, what we're doing is that we are going to, over the next couple of lectures, so this lecture, I'm planning on tackling a few more Monte Carlo problems, including introducing the pig lab. Okay, the pig lab has already been pushed back. I pushed it back to the 15th, but that doesn't mean you shouldn't be working on it. I just simply gave you extra time on it. I'll be going over different parts of it incrementally. So definitely want to go over that. On the 7th, we have you have the pre-proposal and GitHub lab due. So tomorrow, so on Thursday, my plan is I'm going to go over the pre-proposal on how to fill that out and how to do that on and how to use GitHub, as well as going over different ideas for the for your final project. So Thursday, that's what we're doing. We're going over your final project. Okay. Then on the 7th, we're going to go over probably more of the final project stuff, and different ideas and introducing those topics, as well as a bit more review of the topics we need for exam 2. Then on the, so that will be the day the proposals due. Then on the 9th, that's when your proposal is due. So that's going to be what I generally call proposal day. I'll send out a link in advance, an announcement in advance. But on proposal day, that will be held over Zoom again. That one I always hold over Zoom because we don't, it's not a traditional lecture. You're meeting with me and I'm okay. And I'm taking a look at your proposal and I'm okaying it. I'm saying, okay, let me look at your proposal. Is it good? Does it need some work? You know, if you don't have an idea of what to do, that's where I help you figure it out on the spot. The proposal is meant to be as final as possible. That's why we have the pre-proposal. That's why we do the pre-proposal and the brainstorming tomorrow on Thursday. The proposal is meant to be as basically as formal as basically final as possible. If it ends up to be, you're biting off more than you can chew, that's okay. You're just meant to, at that point, figure out what you can get finished in that same context. Okay. So that will, and then after that, again, on the 14th, we'll do a review. And and on the 16th, we'll do the exam. The plan is to teach you how to use the basics of GitHub, how to create repos. There can be 3 for a group in your final project. You can decide to do the project alone or in a group. So your group can be of size 1, size 2, or size 3 people. I don't make exceptions for that. If you want to make a group of size 4, generally my suggestion is to make 2 groups of size 2. Because it gets, at that point, it becomes way too easy for one person not to really do much work or for other people to do work. They do not have to be in your lab section. They can be anyone else, and they can be anyone in the class. They don't have to be in the same section. And I figure out which section they're judged on based on who turns it in. Okay. There is a final project and a final exam. Yes. The final project is due December 11th, and then we'll take the final exam. The final exam is going to be a lot like exam 2, just with a bigger selection of things. All right. Any other questions before I continue on to go over the next homework, which is PIG, due November 15th. So I'm giving you plenty of time. Oh, excellent question. How do you demo it? The answer is that you're going to be recording a video. I don't have time for you to come and demo it for me. So what you're going to do is you're going to submit a 1 to 2 minute video detailing your project. Please do your best to keep it trimmed down. I don't know when the final exam is. I typically figure that out closer to the end of the semester. It's whatever is appropriate for this time slot. The difficulty for our time slot is that this is okay. I'll figure it out. So final exams. Let's find out when our final exam is, shall we? Previous is Temple final exam schedulable. Nope, only one person needs to upload a video. I'll get into that second. Final exam. So we look, even though you are registered for 4 hours, only 3 of those are lecture hours. So we look over here for the day meeting 3 credit hours. And first thing I do is I scroll down here. Are we listed as CIS? Nope, we are neither of those classes. So we don't have a common final, which means that we look over here for 2 o'clock, Tuesday, Thursday. So it is on 12/19 from 1 to 3. So now for what you do is that only one person needs to submit it. What the other people should submit maybe is like, hey, look at this person's work to give me a grade. No worries about that though. As long as people's names are listed, we'll eventually put the grades in. So you'll submit a 1 to 2 minute video detailing your project. The video can be uploaded to Canvas or linked elsewhere, so long as it's obvious and easy for us to find. Include the URL to your video submission in Canvas. Yes, that is true. Your video should be a walkthrough, slide, screenshots, voiceover, and or live action. It doesn't really matter how you do it, so long as it gives us the information about what the project is. It's a general overview. Any technical difficulties can go into the README file. But it's a general overview. Please no more than 5 minutes, because I have to watch like anywhere between. I generally have to watch like 50 to 100 of these things, depending on how many students, how many groups there are. And I have to do it in 1 day, because the best final projects skip the final exam. So Monday, last day of class. Tuesday is and then you've got the study day, right? And during that study day, what I do is I figure out which of you get to skip the final. Yep, it's basically just a video demoing and explaining your final project. Also, you'll want to you also need to submit it to your final project to GitHub. Now, the reason for this is because GitHub, okay, well, here's the thing. You don't get to use my dog ate my homework, or my computer crashed, or it was on a flash drive and it got dropped into a puddle. You don't get to use that excuse in my class. Not for the final project, because the final project is on GitHub, and it stays on, and GitHub will work. GitHub is not, I will go over what GitHub is on Thursday and how you use it. But specifically what we're talking about is using Git. Once you have learned to use Git, there is no more excuse for basically ever saying, I lost my stuff. You're in a programming class. You have access to the internet basically everywhere. So let's see. And yes, how many of the best ones? I generally do at least 1, no more than 2 in a single section for the project that get a skip. Okay. If you're making a game, no, if you're making a game, I'm less interested in the code and more interested in the game itself. I'm interested in the product, not the code. I can look at the code on my own. It's out there on GitHub. Will I assign someone the group if they're not in a group? Nope, you get to do it yourself. It's a group of 1, 2, or 3. I'm not going to be stuffing anybody into any groups unless they want to be found into a group. This is not meant to be a group project unless you want it to be a group project. And again, the more people you have in the group, the more I expect. Not too much more, but like, no, you cannot commit any felonies as part of your final project. Does the story length matter? No, it does not. the can I give you, well, I will go over examples. So I will go over examples on Thursday of final projects that aren't games. There's a lot of them. But if you want to get a head start on brainstorming, if you scroll all the way down to this module 11, module 11 has these different tracks that, so this entire final project comes from the CS50 ID. Okay, from the CS50 course done by Harvard. Okay. And what we do with that is that means that they had these lecture videos in case you don't know what to do. So if you have no idea what to do, you choose one of these 3 tracks: games, mobiles, or web, and you learn one of those, and you basically go through the walkthroughs. So does it have to be in Python? No. In fact, it can be in any language you want, except for Malboge or Ook. I suppose you could do it in Ook if you really want to. Is it legal to make a gambling game? As long as the game is legal and you're not probably doing, although I highly recommend about it being, actual money involved. But I've had people make blackjack games, just there's, no actual money involved in your game. Because the amount of effort and security that has to go with something that actually, involves money is non-trivial. Okay. Any more questions? All right. Pig. That wasn't an insult directed at anyone. This is just simply the name of the game. Okay. This is your assignment on Monte Carlo. Some guy named Todd Neller came up with it. I mark you excused from the final exam. That's how it works. And then look, I'll be blunt. If you get the final project, you're not in a situation where you generally have to worry about your grades. But it works out generally. So in this assignment, we'll be implementing a 2-player a dice game called Pig. It has 2 modes. So in the end, we'll have 2 modes: a single-player mode and a 2-player mode against the computer. Sorry, a 2-player mode, single-player mode against the computer. We will be applying the data analysis to create a good but simple strategy for the computer to use. So we'll also be doing a number of smaller exercises to build up. So this is made of 8 smaller exercises, including 2 Monte Carlo. 2 of those are Monte Carlo approximations. Okay. So the rules of Pig are as follows. Okay. Give me 1 second to, let's see. So it's a dice game. So I need a 6-sided die. No, that's a fudge die. Wrong kind die. 20-sided die. 8-sided die. 10-sided die. No. Okay, here we go. 6-sided die. All right, 6-sided die here. Everybody can see that. It's a standard 6-sided die, just happens to be blue. Okay. So 6-sided die requires only one of these things, which makes it very easy to play. What you're doing is that you're playing against one other person and you're racing to 100. Ostensibly, you could do it with more than one other person, but it makes sense, the most sense for 2-player. Okay. What you do is that you roll this die. Okay. We roll the die and until we get a 1. So I just rolled a 3. And at this point, I can decide, okay, do I want to hold, in which case I get to keep all the points I made for the turn, or do I want to keep rolling? So let's say I want to decide I keep rolling. I rolled a 5, and the 5, and so now I've got a total of 8 points, and I can decide to either keep rolling or stop for the turn. I'm going to stop. The other player goes. My turn again. So I've got 8 points banked. Let's see how many I can get this turn. I got a 6. So now another 6, a 5. It's going pretty good. a 3, another 3, a 5, fantastic, 3. This is going, and I just rolled a 1. Should have stopped earlier, because when you roll a 1, your turn immediately stops. You lose all the points you made that turn. Basically, you get 0 for the turn. And so I still have 8 points. I mean, I didn't lose any of the ones I banked, but that nice streak of a bunch of 6s and 5s all went to waste. Right? The idea here is you try, and so that's the idea of this game. You race until you get to 100 points. The idea here is you can keep rolling as long as you want, but once you hit that 1, you're done. And you don't get any points. So there's the rule. Okay. And you can understand kind of the intensity of that, right? First roll doesn't really matter. There's nothing on the on stakes, but after you've made like 3 rolls or so, you really got to think, do I want to risk it all? It's only a 1 in 6 for this individual roll. It's only a 1 in 6 chance that I'll have an issue, but the odds get higher and higher the more you roll. I mean, they're always 1 in 6 for any individual roll, but overall, the chances of making it without rolling a 1 become harder. Okay. So the first thing we're going to do for this program is that we are going to write, we're going to write some basic computer strategy. We're going to look at a computer strategy. Now, understand, this is very important. Please refer back here for the lecture. When I tell you to go and redo this and fix it. This is describing the strategy for the computer called hold at 20. There's no rule that says you have to stop at 20 points. That is merely the strategy that the computer is going to use here that we're going to be taking a look at. It is a very useful heuristic. The idea here is that we are going to simulate a single turn for the computer. And the computer has to decide, hey, do I want to keep rolling or do I want to stop? Now we could try like making a decision like, based off of how many points I've gotten so far and how many points I've scored this turn, but we're going to keep it simple, a simple strategy for the computer to use called hold at 20. And the idea is that the computer is going to aim to get at least 20 points in a turn. As soon as it gets to 20 or more points, the computer will stop. Make sense to everybody? Everybody following so far? So awesome. So here's some example outputs for the turn for this. Here the computer rolled a 4, 5, and a 6 and a 5, which ends up being 20 points. So awesome, got 20 for the turn. Do some more input. The computer rolled a 3 and a 1. The 1 means the turn total is 0. Okay. And then finally over here, we see another output, and it is possible to get more than 21 because like you could end up at like 18 or 19 points. And then if you're at 19 points, you definitely need to get more than 1 point. But once you're at 20 or more points, the computer stops. That's the goal of this program. Okay. So part 2, and we're going to do at least part 1 today, is the hold at 20 outcomes. So given a number of hold at 20 turns, report the estimated probabilities of the possible scoring outcomes. What does that mean? It's easier to see with our examples. Enter a single positive integer indicating the number of turns simulated. Output, it should be how many simulations do you want? Then we print out the score and estimated probability separated by a tab. So in other words, what I asked them for is how many of these. So what we're doing is in program 1, we're doing 1 automated turn of this hold at 20 strategy. Now we want to analyze how effective that strategy is on the next part by basically doing a Monte Carlo approximation. I think this is a good task for today. Okay. And then I will leave part 3 to you until later. So let's see where we go with this. Okay. Now, the wonderful thing about this is that I should be able to once I'm done writing this, I should be able to just simply drop it in there. And if I can't because the Python file is blocked, I'll just simply drop it in Discord. So let me go ahead and open up idle. Okay. Actually, I'm going to open up VS Code because with my screen, I don't want to share the entire screen. Otherwise, we'll be living the ultra wide life, and that becomes very hard to read very quickly. Okay. So let me get this file set up. I'm going to go ahead and put it into Documents, GitHub, Classroom. Pig 2023. Okay, and now I will go ahead and share my screen. Okay. So here we go. Preferences, settings. Let's go ahead and up that to 32. There we go. Okay. So let's see. Import math. We're going to need that. Now we don't need math, I don't think, but what we definitely need is import random. Okay, save. Now, let's go ahead and pull up the rules and just kind of put them in here for part 1. Alt-Z to turn on line wrapping. So first exercise, we're simulating a turn a pig where the player rolls until a 1 is rolled or until the turn is greater than or equal to 20. We will call this result, hold it 20. Okay, the user doesn't need to make any choices, right? Doesn't need to make any choices. There we go. Okay, so first thing we want to do is that whenever we're doing a Monte Carlo approximation of a game that involves dice rolling, right? What we're going to want to do is actually make a dice to roll. So I'm going to call this def roll d6. That's just simple dice. That there's this type of dice notation that's been standardized in a lot of tabletop RPGs. A d6 just simply stands for a 6-sided die. So what we do is to roll a 6-sided die is we need to generate a random number from 1 to 6. Random.rand int is how we do so. Now, this is the only time this happens in our classes. Only time where we have a start point and a stop point, but it's inclusive of both ends. A random integer in the range A to B. 1 to 6. Very straightforward like that. And we can just simply return that number. So let's go ahead and print roll d6. Remember to invoke the function. Whoopsie. And deny. Oh, yes. There we go. Remember to invoke the function. And there we go. Run it. And we got a 6 there. 3, 2. So it gives me a different thing every time I run it. Okay. Which is great. Okay. Now, let's see. So now we've got because otherwise we'd have to just do this random call all the time and it gets irritating very quickly. The next part is we need to simulate a turn. So def simulate I'll call it sim hold at 20 turn. I know that's a bit of a actually, let's not even simulate it. We're doing it. So I'll just call it hold at 20 turn. It's a bit of a mouthful, but for right now, that will work. So the idea here is that we need to what is this trying to do? The idea right now is that we're going to be printing out stuff, but in the future, we know in the future that we're going to be using this function, and we're going to be running this, and it's going to give us a score. Okay, so the computer's entire point is that it's going to try and get as many points as possible. So turn total. And the reason I'm calling it turn total rather than score or total is because, right, we're going to be having multiple totals. We have two totals we care about. The score for the turn and then our overall score. So just going to call it turn total to basically say this is the total number of points we got this turn. It's 0, right? That's how many points we start out with. And at the end, whatever it is, we want to give that amount back. Just again, trying to figure, it's always a good practice to figure out what the input and output are going to be. And as I mentioned before, though, for this first time, we're not really going to be returning anything. We're going to be printing it first, right? Because the output, right now we just want to print the turn total. Similarly with there we go. We're going to print the turn total. Okay. And so now what we want to do is while our turn total is less than 20 points, while we have less than 20 points, we want to basically keep rolling, right? So let's go ahead and do that. While we have less than 20 points, let's get us some points by rolling the die. Okay, so we do roll d6, and we say turn total. Let's go ahead and actually, because we want to print this out, result. Yes, let's see. Why is there parentheses after turn total? Because I made an error there. I was typing and talking. Let's call it points is equal to roll d6. Okay. And then turn total plus equals points. What about ones? Some of you are screaming. Don't worry. For right now, I'm ignoring the 1. Hold at 20 turn. Okay. So here, what we got is we've got a 24 points here, 21 points. So it stops after getting 20 points or more. So the output, though, is that it wants something that looks like this for the outputs. Let's go ahead and drop that in over here to see what our outputs look like. Roll 6, roll 5, turn total 20. Print. Let's go ahead and do the turn total. Print, comma, turn total. And then over here, what we're going to do is this is the reason I had it split up into 2 lines, print roll, points. And there we go. We ran it once and it prints out the number of points that we made. Okay. And now I will upload the practice exam probably on Friday. Not Friday, or probably later, but not tonight. I've got a lot of stuff to do to get ready for Halloween. 1, 2, 2, 5, 3. Also, I'm covering a lot of registration duties right now. So because it's that time of the semester at the moment. So 1, 2, 3. So notice that we're supposed to stop when we roll a 1, and that should terminate the number of points we get. So there's a few different ways we could go about this. Okay, which is we could do an if over here, and we're gonna need to do an if. But yeah, let's do an if over here. So we get the points. If points equals 1. Now it's very important that we do if points equals 1 as opposed to if roll d6 is equal to 1, because this generates a new random number and this would generate a new random number, which may or may not be the same random number. So we take the random number and we store it. If points is equal to 1, well, regardless, let's go ahead and do the thing what we know we want to do regardless. If we roll it, we say roll points. If points is equal to 1, then what we want to do is we want to say then turn total is equal to 0. Else turn total plus equals the number of points. Okay. Now, of course, we still have a bit more to do. If we roll this, then all that happens is that we get into some interesting situations. Let's see. Where's that? Come on, I'm looking for a 1. Still doesn't stop after we get a 1 because we haven't told it to stop. We only simply said that it loses all the points it's already made when it gets a 1. So what we have to do here is that we have to tell it to stop. There's a few ways to do that. The first way to tell it to stop is using the special keyword break. I don't like using break because it's a bit inelegant, but it works. Feels like there was probably, when you use break a lot of the time, I feel like there was a better solution that you could probably come up with, but maybe not. Works pretty well there. But break basically means we stop the loop. You could use it with, another flag, like and not done, and then set done is equal to true on either of those. But honestly, I think here it does make sense to break. Make sense? And so there we are. We're done with part 1. Does this make sense to everybody? The other one is, so turn total, while turn total is less than 20, points is equal to d6. The else statement should be fine because if the roll was 1 point, then we reset it. Otherwise, we add the points in. And then the while loop just simply keeps repeating it. So points keeps getting reset at the top of the loop over here. So it should be fine. And we're getting our expected behaviors here. Yeah, I appreciate the compliment about me being able to do this on Zoom. I put in a lot of effort before COVID to make sure. Look, there was a mumps outbreak back in 2019. And I had already been teaching online in different contexts. So I was like, hey, you should totally prepare to hold your, you should, have some practices about recording your lectures because you want them to be available for students who are sick in case there's an outbreak. So yes, I was the best semester that I've ever the semester that I've ever got the best scoring from students on was spring 2020. That was the semester that basically everything went crazy in the middle of it. And we went virtual in the middle of it. But I've already been teaching virtual. I've already done this kind of stuff basically since 2016. So, okay, deaf. So now we want to move on to part 2. So we want to simulate and better, it's easier to see what's going on over here. All right. Simulate the number of probability. Simulate a number of hold at 20 turns and report the estimated probabilities of the possible scoring outcomes. So, and we want to see what it looks, and I'll just simply say show what it looks like over here, what the output looks like. So simulate a given number of hold at 20 turns and report the estimated probabilities of the possible scoring outcomes. How many hold at 20 turn simulations? I want to do 1,000,000, and then it says, here's the score and the probability. We'll get into that into a second. So the idea here is that we are going to take this and we're going to run this possibly 1,000,000 times, definitely in the thousands, to see what, and we're going to see what the results are. And what we're going to do is that we want to count how many of basically each result we get. We want to count how many zeros, how many 20s, 21s, 22s, 23, 24s, and 25s. Why these numbers? Because you get a 0 when you roll a 1. You get 20 when you exactly land on this number. You get a 25 because that's the largest value you can make with this strategy. Because the only way you get a 25 is that if you had a 19 to start your turn and then you roll 6. So that's why that's the largest number, and everything else is just simply in between with different outcomes leading to that. Make sense? So 20 is just simply, that's our stopping point. And then over here is you had to have a 19 followed by a 6. So, and what we're going to do is that we are going to count how many of each result we have, then divide by the number of trials, and that gets you a probability. So and we'll work our way up there so you can see what I'm doing. 0, for instance, 62% of the time, we'd get no points. We'd roll 1. And then the rest of the time was about 10% for 20 and 21 points, and then 7, 5, 3, and 1% for the rest of them. So we definitely want to do hold at 20 turn and use that. So we're going to slightly rewrite that. I'm going to comment, what I'm going to do is I'm going to make 2 minor changes. First, I'm going to comment out the print statement because I don't want to, if I'm going to be running 1,000,000 of these, I don't want it to print out 1,000,000 times, right? So in that case, I comment this out. That's change number 1. And change number 2 is I'm going to return the turn total rather than printing it out. Just simply give it back to us. Remember, printing is eyes for the human. Return means it's for the computer's eyes. Okay. Def 20 estimated probabilities. Okay. At 20 sim. And then rather than taking an input here, I will basically say, rather than asking the user for the input, I'll do that outside the function or leave it to you to do. Instead, what we'll do is we will take in the number of trials. How many simulations we want to do? Trials. All right. Number of trials we want to do here. So the first thing we need to do is have a way of keeping track of our results. And there's basically one way we could go about this, which is we could do there's 2 ways. We could do like variables, num0 is equal to this, num20s. How many times did we see a 20? How many times did I see a 21? And this works for this exercise. However, let me introduce you to part 3 of our homework, which is why we're going to do something different. If we do it like this, part 3, if we do it a different way, the second way that I'm going to show you, part 3 becomes a lot easier to do. Which simply says, rather than being hold at 20, we want to make it hold at any specified number. Right? We want to be able to test out the various, okay, we're choosing 20 as the strategy for the human for right now. but what happens if we choose a different number? Okay. So that's part 3. Part 2, we're just going to do this one. So for this, instead, what we're going to do is we're going to hold our results in a dictionary. Turn results. That pause there and me deleting stuff before rewriting it was my fingers moving quicker than my brain was, because it's like, wait, what are you doing? Oh, right, return. So results. So what we're going to do is that we are going to, for this one, we know what the outcomes are going to be, right? It's going to be 0, 21, 20, 21. Okay, and now 1, 4. Okay. 21s, 22s, 23, 24. This way that there's going to be something less for us to do other than change flipping a few things. But there we go. So there we go. Those are the possible outcomes for our simulation. And we set the key to be the outcome, and the result and the value is the number of times we've seen that outcome. Make sense? So what we do is now actually very straightforward. We do a for loop. It says for in range trials. We're going to say turn total is equal to hold at 20 turn, right? We're going to simulate a turn, get, right? That's the thing we read it. You definitely will be built. Parts 1, 2, and 3 are built off of each other. Parts 4, 5, and 6 are built off of each other. It's possible to basically do an iterative evolution of this thing, but you'll see. Turn total is equal to hold at 20. I like to modify my previous parts to make it work for the future part. All I had to do for this part is I just commented those. Turn total is equal to hold at 20 turn. And that's going to be our result, essentially the result for that turn. And so what we do is that we said, okay, is this a 0, a 20, a 21? Right. And we could just simply, the not good way to do it is if turn total equals 0, then do results 0 plus equals 1, increment that 1, and then do it like this. If it's 20, then change the key that is 20 to be 1 more, right? We could do it like that, but it's no fun that way. Instead, what we'll do is we'll say results, and we'll just simply notice this over here, that whatever we're checking is going to be the key. So what we might as well do is just simply say turn total of that key plus equals 1. Okay. So here we go, hold at X outcomes, and we are going to print hold at sim results. Sim. We'll do 1,000 simulations. And we're not done yet anywhere. We're not anywhere close to done with this yet, but hey. 0, 26, 623, 20, 87, 2197. So we see these results and they kind of match up, like 623 being 62% of that total. So we should be see about 6,200 here with 10,000. All right. But what we need is percentages, and we also want it to look nice. So what did we want it to say? We wanted to say, so let's go ahead and say score estimated probability. That /t is to make a tab. And what we'll do over here now is that I will say results is equal to hold a 20 sim. And then what do we want trials? We want, let's just do 1,000 for right now. And then for score in results, what we're going to do is we're going to print what that score is, the key, and we're going to print out the number of times we got that, which is going to be results score, the number of times we saw that score. And then finally, what I'm going to do is I'm going to say sep equals /t. So here, what I'm doing is that with the comma, I'm saying, hey, if I've got things listed by commas in this print statement, separate them out by a tab. Okay, and now we need to just turn these into probabilities. So what we need to do over here is we've got trials over here. And then what we want to do is, oh, I can do that. Okay. So what I want to do is I want to apply, I want to take this and say basically for each of the scores in the results, take our results of that score and set it equal to the same value. I want to take each of the values for that and divide it by trials. Okay. What is this line? What I'm saying is that for every one of these keys, 0, 20, 21, 22, I want to take the number that was in here. So in this case, that was like 6,400. And I want to divide it by the number of trials. That will turn it from a value, from a number like 6,400 to 0.64. It wasn't 6,400. It was 64 in this case. Let's take it. So it takes it from something like 64, divides it by 1,000. So we get 0.64 to get a percentage. Make sense? Now, what I could do on the other hand, though, is I could do advanced black magic instead, I believe, by doing would it be able to? Does it work on that or no? What does map do? Give me a second. I always forget. Oof, that looks terrible. Map, I forget how that works on dictionaries because normally what I do for, sorry, I'm rambling here. No, map would not work for this. Or, I mean, it would. I just don't. Yeah, let's see. Map. Hold on. Sorry. Indulge me. Lambda X. X. Okay, yes, it works, but how do I get it out? Yeah, no, okay. Can't figure it out after in 30 seconds. So nope, we're going back to the way I was doing it before. Was hoping I could use it as an example for doing a lambda, but I'm not exactly sure how to work with lambda expressions in dictionaries, or sorry, with map in dictionaries. I can do lambda expressions all day. But there was no need for that. Okay. So what we did over here is that we took the for loop and we took our results and we modified that over there. We could also do the same thing instead of doing it in here, is we could just simply do that over here. Well, except we'd have to, copy paste that number in. So I find it easier because we know what the amount is over here. Do that. And now let's do 1,000,000 of these simulations. And that takes a bit to do 1,000,000, but it does it. And there you go. And yes, you could change your hold at 20 to be a hold at X and to do that. Now, the hold at X is pretty interesting, which is part 3, and I'm not going to do part 3 today. I want you to take a handle on that one. Okay. The hold at 20, the way that one, sorry, the hold at X is basically saying instead of holding at 20, right? Instead of being at a hold at 20 turn, it'd be a hold at X turn, where X is this amount. The costume is Papyrus's dating outfit from Undertale. Normally he's in armor, and instead we are in this is what he wears when he goes on a date, which goes hilarious. Goes exactly how you'd expect a date with a skeleton who loves spaghetti would go. So anyway, let's see. Hold at X outcomes, right? Here, there's nothing stopping us from like doing a hold at 20 turn or a hold at 10 turn, although we'd have to change the probabilities that go into here. In fact, that's what you want to do with the hold at X. With the hold at X function, instead of preloading all these, okay, so I'm going to break this a bit to make it easier for you to do hold at X. Instead, what you do is this. Have it blank because you don't know what your results are going to be, because you don't know if you're doing hold at X, the strategy could be 30, in which case you're never going to get any of these results. So in that case, you would get 30s. So here we would say turn total is equal to hold at 20 turn results. And then we would do then we'd have to do the if else statement that you're going to have to learn to use dictionaries for. When this part will definitely be, this is the kind of statement you definitely would have to make on an exam, which is if turn total is this a value that we've seen in the results. So suppose we don't know what the outcomes are going to be. We do our simulation and we get the outcome. We ask, hey, if that's in the results, great. Then we just simply increment the number of times I've seen that result by 1. Otherwise, it was not in the results. So this is the first time we've seen it. So turn total is equal to 1. And then it's running now. And there we go. Goes in order like that. And then let me do 1,000. Let me just do 1,000 and see if it pops up, if we get an issue popping up. Yep, there we go. So in case you missed that, 0s, 25, we get our results and our results are correct. They just happen to be out of order, because when we put things into a dictionary, it keeps them in the order that it was added in Python. Make sense? Okay. No. Okay. So the reason this came out in this order is because what happened is that we got a few zero results from we rolled a 1 a few times, therefore we got a score of 0. And so we said, okay, is 0 in results? No, it's not. So we establish it as 1. Oh, we see a 0 again. Yes, we're going to need to sort the dictionary in a bit, but right now that's not a problem we have to deal with. So then we run this again, and even though getting a 25 is the least likely outcome, that's what happened the next time around. So we got a 25. We asked, is it in the results? So it was like, okay, I see zeros, and now I see a 25. So those are 2 of the possible results. Then we rolled and got a 21, and it's like, aha, 21s are part of the results. One of the things you got to understand when we do dictionaries is that there is no order except for what we impose on them. In this case, we could probably easily do just simply sorted over here. And does that work? Yes, it does. And that just simply works. Just saying, hey, sort it. And by default, it's going to sort by keys, which is exactly what we want here. All right. So that is most of what you need to do this problem. Let's go ahead and stop sharing for a sec. So let's see if I can drop this into yeah, let's go ahead and see if I can drop this into chat. Oh, there's an open reveal in File Explorer. Wonderful. Wonderful. Okay, simply replying to which lectures? The lecture recordings? The lecture recordings, front page of Canvas, there's something called there's a link in red dead center called lecture recordings. It's just easy to miss because it's like looks very generic, but it's also under important links. Sorry, got distracted there. Let's go ahead, drop it. Can I drop it in here? And send. There we go. Should be able to download what I just sent to you, or what I just did there. Okay. So plan on Thursday is to go over GitHub. Okay. I will post a practice exam once I figure out what I really want to be on the exam. The practice, let me just go ahead and while I've got my mind on it, and while I'm not sharing my screen, let me go ahead and take a look at the actual exams from exam 2 and exam 3. Again, there's no exam 3. There's only 2 midterms here and a final. Okay, so exam 2. So for exam 2, I asked a grand total of 6 questions, apparently, on the exam. One was on basically, first one was dealing with a list of strings, figuring out which of the string was the most special by some definition of special. And then we had another one that was given a list of integers, write a function called, and it might be something like, you know, sum of tens, which simple, and then would basically give me all, you know, sum of all the numbers in the list that are multiples of 10. Few other things. My first iteration of exam 2, it should be the first time I gave it out. The first time I did this exam, so I'll be honest with you. First time I did exam 2, after COVID was terrible. This very exam that you're about to take, it went really poorly because I tried to do it in a 50-minute time period. So the overall consensus for that exam, and it bore out after trying it in the other in other contexts, was that it was a was that the, well, I was trying something experimental called a 2-stage examination, and that didn't that just the exam 2 just went very poorly with the amount of time it had. Once we gave the students more time, which was closer to which was around 75 minutes, closer to the actual amount of time you'd get, they did much better. No, I don't know. I don't sing well. I like Deltarune. I'm excited that we got an email last night saying chapter 3 is now fully playable, and that instead of trying to release chapters 2, 3, 4, and 5 as a bundle, he'll just do 3 and 4. No, I've not done stand up. I might do it at some point. Deltarune, I am very excited for. It's I think that Toby Fox's games are absolute gems. Going back to the exam though, this one I don't think it's too tricky because I'm letting you know what's in on it. The only thing that's going to be different is I'll probably swap out one of the questions to also include a Monte Carlo. But again, there's not going to be many questions. What you're going to get is okay, let's go ahead and, all right, here you go. I'm going to throw y'all a bone. Let's throw y'all a bone. Okay, I can come up with a different question this year. I don't have to be, I'm allowed to be. Let's go ahead and take a look at the first 2 questions from last year's exam. Okay. Okay, so here we go. So this is the way that it looked last year. Okay. Because I need to switch out questions for Monte Carlo, and I might switch out this one, I think, because it's the least important for testing, or I can just change it. So the first 2 questions went together. First was write a function called isVal that returns true if and only if this given string is a val. And so notice how I give it. I give you the function, I give you input-output pairs, and then I tell you how I'm going to grade this one. 5 points for detecting a val, and then 5 points for returning true or false. Here, this one definitely is much more indicative of the way you might see the rubric and how that works. So write a function called most vals. Given a list of strings, return the string with the most vals. If there's a tie, you decide how to handle that. Meaning, I don't care, don't bother me about it. Just do something. And doing nothing is doing something in that case. You may call the isVal function you wrote from the previous question and assume it's correct. So here, most vals, like we've got hello, world, and now. Hello, because that gets returned because it has 2 vals, and most vals over here return the because that has 4 vals. Now the grading is out of 15 points. Over here, I say that it's 5 points for iterating over the list, 5 points for finding the string with the largest number of vowels, and 5 points for correctly returning / not creating other errors. So this gives you an idea here. Is like, okay, I don't know how to find the one with the most vowels, but I do know how to iterate through a list. Might as well get 5 points for that. And then once you figure out, oh, right, I iterated through the list. Now I can look at this to try to find the string with the largest number of vowels and do that part. Make sense? So I give you a rubric that also, helps. Elio, you will want to refer to Thursday's lecture. I do that in Thursday's lecture, where I sort on the values. Can I repeat the topics? And it's impossible for me to repeat the topics. I don't think I ever actually went over them. But what we're going to do is basically what you'd expect to do is Monte Carlos. So here's what to expect from reverse for exam 2. Monte Carlo approximations. So that means, and basically everything that has to go with them. In other words, generating either a random number or a random dice roll. Sorry, random dice roll, a random card. It's most likely going to be either a card game. I'm going to give you a card game or a dice game or a coin game. One of those three things. Coin game meaning a game where the results are based off heads and tails. A card game meaning that we're just trying to figure out something with cards, like the red black game. And then yes, you can still do the runestones, or a dice game like Pig. Okay. And it will most likely be presented in the form of a scam saying that you've been proposed to play a game, and here's the rules, and oh, here's the odds. It's so easy. You've got like a 50% shot of winning, so it's just pure luck. And in reality, the rules are rigged, and so you're trying to figure out what the real odds of the game. Deadline is last day of classes, December 11th. I will have to work on getting you chapter numbers, because again, the Monte Carlo is kind of its own self-contained thing from the projects. The file reading is another important one. That's definitely a 20-point question on the exam. Given a file, parse the file and do something with it. Another question would and then a lot of the other questions will be like going over lists and strings, iterating over lists and strings. Okay. So, and I also want to emphasize that Monte Carlo is the last of the mandatory kind of stuff that I teach. The GitHub stuff is for your final project. You won't be tested on that, but you'll need to use it. Yes, dictionaries will be on the exam. I kind of blanked on that. So yes, dictionaries will definitely also need to be on the exam. While loops are going to be just tested as part of, for loops definitely need to be tested, but they're going to be part of iterating over strings. While loops are definitely going to be tested because you need the while loops to do the Monte Carlo approximations. Possibly. Depends on the kind of question you get. Dictionaries are going to be on the exam. I was thinking of dictionaries already in terms of Monte Carlo approximations. The dictionary question will most likely be something along the lines of, hey, given a bunch of text, what is the most common word? I plan on meeting in person on this Thursday. I mean, I have to be on campus. I've got a Japanese test to take on the 2nd, but on the 9th, that's probably going to be over Zoom. Even if I am at school, we're definitely going to probably do that over Zoom. Oh, or maybe not, or maybe I'll do it both, hybrid on Zoom and not on Zoom. We'll figure that out. But the point being is that for Friday, I don't want people to have to commute in for. Sorry, not for Thursday. For the 9th, I don't want people to have to commute in. Okay. So that's for the 9th. All right. So happy Halloween, everybody. If you need to speak with me, I will stick around for a bit.